Hey everyone, and welcome back for another deep dive. Today we're going to be looking into something I think you're going to find really interesting, electric spacecraft propulsion. You send over some pieces of that Wikipedia article on it, and wow.
It's a lot to unpack.
Yeah, there's some really fascinating stuff in there. Ready to dig in.
Absolutely. It's funny. A lot of folks think electric propulsion is this like brand new thing,
Yeah.
but it's been around for a while.
The Wikipedia article mentions this Konstantin Tsiolkovsky guy,
Oh yeah.
and he was talking about this stuff way back in 1911.
Yeah, he was a visionary.
That's before Model Ts even.
Right.
So who was this guy? What's the deal with Tsiolkovsky?
Well, he was a rocket scientist,
Mhm.
like way ahead of his time, really. I mean, he's considered one of the founding fathers of, all this rocketry and space travel stuff.
So this guy was basically predicting the future of space travel. But I guess the question is, like, what is electric propulsion? That Wikipedia article's definition is a little, technical. Something about using electrostatic or electromagnetic fields to accelerate mass.
Yeah, it's a mouthful.
Yeah.
A mouthful.
It's a little hard to wrap your head around.
Yeah. So basically, instead of like a big fiery explosion like you get with those chemical rockets, electric propulsion is more of a gentle, like continuous push.
Yeah.
It uses electricity to accelerate ions, and that creates thrust.
Oh, so it's more like gliding through space then.
In a way, yeah.
That's got to be a lot more peaceful.
Yeah. And because of that gentle, continuous thrust, it's super efficient.
Yeah.
Like the Wikipedia article even mentions how electric thrusters get much higher exhaust speeds
Yeah.
than chemical rockets, so they need way less propellant.
Okay, so that's going to be huge for those long missions, right?
Absolutely.
Like imagine sending people to Jupiter's moon Europa.
Yeah,
You'd need a ridiculous amount of fuel just to get there and back with chemical rockets.
for sure. And that's why electric propulsion is so exciting. For missions to Europa, to Mars, even beyond.
Yeah.
I mean, the Wikipedia article even says that like an electric-powered ship, you could potentially carry 70% of its initial mass all the way to Mars.
Wow.
But the chemical rocket, you're talking like a few percent.
Okay, so 70%. So we could send way more stuff,
Yeah.
more equipment, more supplies.
Absolutely.
I mean, maybe even like build a whole habitat, a decent sized habitat on Mars.
Exactly. It changes the whole game.
Yeah, but okay, so if electric propulsion is so great, why aren't we using it for everything? There's got to be a catch.
Right. And the article points it out.
What is it?
Power. That's the catch.
Mm.
Even though it's super efficient with fuel, the thrust that you get from electric propulsion is still way weaker than a chemical rocket
Okay.
because we just don't have powerful enough power sources on spacecraft yet.
So it's kind of a trade-off then.
Yeah.
You get efficiency, but you lose raw power.
Precisely. It's great for gradual acceleration, like over long periods of time,
Uh-huh.
but it's not going to get you off the ground.
Makes sense. It's like a marathon runner versus a sprinter,
Yeah, good analogy.
But, the article also mentions the Soviets, they were already messing with electric propulsion
Oh.
way back in the 1930s.
Gas Dynamics Laboratory.
Yeah. And they even tested out like an experimental ion engine on their Zond 1 spacecraft.
Yeah, in 1964.
In 1964, I had no idea it went back that far.
It's been around for a while.
That's wild. So it was like a space race inside the space race.
Kind of, yeah.
Both sides were trying to push this new tech forward.
Yeah, the U.S. was working on it too.
Really, at the same time.
Yeah, NASA was right there with them.
So what happened next? Did one side, take the lead?
Well, they both kept making progress. NASA's CERT-2 mission in 1970,
Okay.
that really showed that the technology worked. And since then, it's been steadily getting better. Different types of electric propulsion have come about,
And that's where things start to get complicated.
Yeah, a little bit.
The article lists all these types: electrostatic, electrothermal, electromagnetic.
Lots of big words.
I'm already getting lost.
Don't worry. It's not as bad as it sounds. They're just different ways of, getting those ions moving to create thrust.
So it's like having different tools in a toolbox, each one for a specific job.
Yeah, that's a good way to think about it.
Okay, I think I can get on board with that. So can we take a look inside this toolbox? What makes each tool, each type, I guess, unique?
Sure, absolutely. Let's start with one of the most well-known types, the gridded ion thruster.
Okay.
It's an electrostatic thruster, and it basically works like a miniature particle accelerator.
Okay, you got my attention. Tell me more.
Okay, so imagine these grids with high voltage going through them,
Uh-huh.
and they create this electric field, and that accelerates ions, usually xenon gas,
Okay.
and it gets them going super fast, and that's what creates the thrust.
So the electric field is like an invisible hand just pushing those ions out the back, and that pushes the spacecraft forward.
That's it. And because you're shooting those ions out so fast, that's what gives you that crazy fuel efficiency.
Okay, that makes sense. So are the other types all about electric fields, or do things get a little more, explosive with the
Well,
others?
if you want explosive, we'd talk about electrothermal thrusters.
Okay, let's do it.
Think about an arc jet.
Okay.
Uses an electric arc, like a mini lightning bolt, basically,
Wow.
to superheat propellant.
So instead of pushing the ions with an electric field, it just blasts out this super hot gas.
You got it.
Is that kind of similar to a chemical rocket then?
It is, in a way, like it uses a nozzle to turn that heat energy into motion,
Yeah.
and that creates the thrust.
Uh-huh.
But the big difference is that the heat comes from electricity, not from burning fuel.
Okay, I'm starting to get how these different approaches work, but you said there were three main types, right?
Right.
We've covered electrostatic and electrothermal. What about electromagnetic thrusters?
Those are where things get really interesting.
Ooh.
They use both electric and magnetic fields working together
Okay.
to get those ions moving and control how they flow. One of the most promising types is called the Hall effect thruster.
Hall effect thruster. That sounds like something straight out of Star Trek.
It kind of does, right?
So how does it work?
So in a Hall effect thruster, you've got a magnetic field,
Mm-hmm.
and that traps electrons, creating this like cloud of electrons.
Okay.
Then you apply an electric field across that cloud, and it accelerates the ions through it.
So it's like the electric and magnetic fields are working together like a tag team to boost those ions up to like warp speed.
That's a great way to put it. And the magnetic field, it's not just accelerating the ions, it's also helping to contain them, focus them into a beam.
So it's like a magnetic funnel, making sure they all go in the right direction.
Yeah, exactly. That makes the thruster even more efficient.
Pretty ingenious. But I can't help but think back to that controversial section in the Wikipedia article.
Oh, yeah.
Things like the quantum vacuum thruster and the EM drive.
Some wild ideas in there.
Yeah, they sound almost too good to be true. Are those even remotely realistic?
Well, those are really pushing the limits of, what we know about physics.
Right.
Like the quantum vacuum thruster, that one's trying to use the energy of empty space itself.
Mm.
And the EM drive, it claims to create thrust without any propellant.
Yeah, that always gets me. How can you have, like, action without a reaction? It's like trying to clap with one hand.
Exactly. That's why a lot of scientists, they're not convinced.
Yeah.
There's been some interesting results in experiments,
Yeah.
but nothing conclusive so far.
So it's more science fiction than science fact for now.
For now, yeah. But who knows? Maybe someday.
Yeah, maybe someday. Speaking of the future, what are some of the ways that electric propulsion could be used, like beyond just getting us from A to B in space?
Well, the article mentions this thing called dynamic properties of electric propulsion,
Okay.
which is a fancy way of saying that it can do more than just push a spacecraft forward,
Uh-huh.
because it gives you that constant low-level thrust. It opens up some cool new ways to maneuver a spacecraft.
Like what? Give me an example.
Like, imagine keeping a spacecraft in a really precise orbit around a planet for a long time.
Okay.
So you can get super detailed observations, scientific observations.
Yeah.
Or imagine, like, you need to adjust a spacecraft's path just slightly.
Yeah.
Meet up with a comet, or an asteroid.
So instead of big, forceful maneuvers with chemical rockets, it's more like, I don't know, like space ballet.
Yeah, like
Yeah.
space ballet. It's all about being super precise and controlled.
It's amazing how electric propulsion is changing how we think about traveling in space. It's not just about brute force anymore. It's about efficiency and precision and just opening up possibilities that we never even thought about before.
That's exciting stuff.
It really is. But before we move on, I want to hear from you, the listener. What are your initial thoughts about all this? What stood out to you so far in our exploration of electric propulsion? Hold on to those thoughts, because in the next part of our deep dive, we're going to go even deeper into the future of this incredible technology. So last time we were talking about all the cool things you can do with electric propulsion, like making a spacecraft, sort of dance around a planet with those super precise movements.
Yeah, they're remarkable.
It's like choreographing space travel. So, okay, let's talk ambitious missions then. Where does electric propulsion really come into its own? What destinations does it open up?
Well, think about the outer solar system.
Oh, okay.
Like the gas giants, Jupiter, Saturn,
Yeah.
Uranus, Neptune.
It's a long way out there.
It's really far. And sunlight is really weak out there, too. So solar power is not as good.
Right, so solar panels would be struggling to, get enough power out that far.
Exactly. So that's where electric propulsion really shines.
Okay.
Because it's so efficient with fuel, you can travel these huge distances without needing to carry a ton of propellant.
So it's like the difference between driving a gas guzzler and an electric car on a road trip.
Exactly.
So instead of being limited to these short little hops around Earth or even quick trips to the moon, we could be sending spacecraft on these grand tours of the outer solar system.
Absolutely.
Imagine exploring the moons of Jupiter or Saturn in detail.
Yeah.
I mean, some of those moons, who knows, they could even have life.
That's one of the most exciting possibilities.
Yeah.
Like Europa, that icy moon of Jupiter. Scientists think there's this huge ocean under the ice.
Yeah.
And electric propulsion could be how we get a probe there, explore what might be down there.
Okay, now I'm getting chills thinking about that.
Pretty wild, right?
Exploring alien oceans. That's amazing. But, okay, let's get back to those different types of electric propulsion.
Sure.
Last time we talked about electrostatic and electrothermal thrusters. You mentioned a third type, electromagnetic.
Right.
Can we unpack that one a bit more?
Absolutely. So electromagnetic thrusters use magnetic fields to, control those ions.
Okay.
One of the most common types is the Hall effect thruster.
Yeah.
And it's already being used on tons of satellites today.
So it's not just some futuristic concept, it's actually being used right now.
It is.
Yeah.
And it's really efficient too.
How does it work?
Okay, so the Hall effect thruster uses a magnetic field and it traps electrons.
Okay.
And that creates what we call a plasma.
All right.
And then an electric field is applied, and that accelerates the ions through the plasma. And that's what creates the thrust.
Okay, so it's a little more complicated than just those electric grids we talked about earlier.
Yeah, a bit more going on.
So what makes these Hall effect thrusters so popular? What's their advantage?
Well, they have a good balance of thrust and efficiency.
Okay.
They're not the most powerful type of thruster,
Mm-hmm.
but they can run for a long time
Yeah.
on relatively low power.
Yeah.
That makes them perfect for things like, keeping a satellite in position
Right.
or even slowly raising its orbit.
So for missions where you need that constant, reliable push over a long period, Hall effect thrusters are the way to go.
Exactly.
It's like having a trusty workhorse for those long space hauls.
I like that analogy.
But okay, I gotta admit, I'm still a little stuck on those controversial concepts from that Wikipedia article.
Yeah, those are fun to think about.
Like the EM drive.
Right.
I know it's still unproven, but the idea of creating thrust without any propellant, that just sounds like magic.
Oh, it does. But that's the cool thing about science, right? Sometimes these crazy ideas turn out to be totally revolutionary.
So you're saying there's still hope for the EM drive?
Mm-hmm.
Maybe one day we'll be zooming around the solar system without worrying about fuel at all.
It's a long shot.
Yeah.
There are fundamental laws of physics that we haven't figured out how to break yet.
Yeah.
But even if the EM drive doesn't work out,
Right.
all the research that's going into it could lead to other breakthroughs.
Yeah. Sometimes it's the journey, not the destination, that's the most interesting part.
Exactly.
But speaking of journeys, with all these different types of electric propulsion, how do we decide which one is the right one for a mission?
It's a good question.
Is it just a matter of picking the most powerful engine?
No, not really.
Okay.
It's more about finding the one that's the best fit for the job.
Right.
It's like choosing the right tool from your toolbox.
Mm-hmm.
You wouldn't use a hammer to tighten a screw, would you?
Okay, so let's play a game then. Let's say we're planning a mission to send a robotic probe to Venus.
Okay.
What kind of electric propulsion system would we want for that?
That's a fun one. Okay, so Venus has this really thick atmosphere.
Right.
So you need something with enough thrust to get through all that atmospheric drag on the way down.
So we'd need something a little more powerful than a Hall effect thruster?
Probably, yeah.
Something that can really push through all that thick Venusian air?
Exactly. Something like a gridded ion thruster might be good.
Okay.
It's got a pretty high thrust-to-power ratio, so it can put out a good amount of thrust without needing a huge power source.
So for that mission, we need something that can handle, that really harsh environment on Venus.
Yeah.
Something that can push through the atmosphere and get our probe down to the surface safely.
Exactly.
It's like picking a truck for an off-road adventure. You need something tough and powerful.
Exactly. And the great thing about electric propulsion is we've got all these options to choose from.
Yeah.
And as the technology gets even better, we'll have even more specialized tools for all kinds of missions.
It's amazing to think about all the possibilities. Electric propulsion is really opening up this new era of space exploration. We can go farther, explore more, and do it all more efficiently.
It's exciting to think about what's coming next.
It really is. But before we get too carried away, I want to hear from you, the listener. What are your thoughts so far?
Yeah.
What about electric propulsion is really sparking your curiosity? hold on to those thoughts. Because in the last part of our deep dive, we're going to explore even more about the future of this incredible technology and how it could shape humanity's future among the stars. Okay, so we've gone from those basic ideas all the way to, talking about specific types of thrusters.
Yeah, we've covered a lot.
But now I want to really let our imaginations run wild.
Okay. Yeah.
What does the future hold for this technology? It feels like we're on the verge of something huge.
It really does. And you know what's really exciting is that electric propulsion isn't just about like doing the missions we already do, but more efficiently.
Right.
It's about doing things that we couldn't even dream of before.
Okay, so give me those possibilities. Hit me with it.
Okay.
What are we talking about? Interstellar travel, warp drives.
Okay, maybe not warp drives just yet.
Okay.
What about building giant structures in space? With electric propulsion, we could move these massive parts, assemble habitats, maybe even build whole space stations without needing those huge, expensive rockets that we use now.
So instead of launching everything pre-built from Earth, we could be like manufacturing in space, using resources we mine from asteroids or the moon and be like a whole space-based economy.
Exactly.
Yeah.
And electric propulsion would be like the engine driving that economy.
Literally, yeah.
Moving materials around, taking people between different outposts, even adjusting the orbits of these huge structures.
Right.
It all becomes possible with this technology.
I mean, it's just crazy to think that we could be on the edge of this whole new era of, human expansion out into space.
Yeah, mind-blowing.
But let's bring things back down to Earth for a second.
Okay.
What about how electric propulsion is affecting things right here, right now?
Yeah, good point.
It can't all be about the distant future.
Well, it's already having a big impact.
Yeah.
Especially in the commercial space industry. Like companies are using electric propulsion for their satellites.
Right.
To make them last longer, make them more maneuverable
Yeah.
and cheaper to operate.
That makes sense. Satellites are already using ion thrusters for things like, station keeping.
Right.
But are we talking about even more ambitious things here?
Oh, for sure. Think about things like space tourism.
Okay.
There are companies working on spacecraft that use electric propulsion to carry passengers up to low Earth orbit and back.
Wow.
It's more efficient, it's quieter.
So those dreams of space vacations might not be that far off.
Yeah, and it's all thanks to this technology that used to be science fiction.
It's incredible how things have changed.
It really is, and it's only going to get faster.
Yeah.
As electric propulsion keeps getting better, more powerful, more efficient, more affordable, who knows what we'll be able to do.
It's like watching a chain reaction, One breakthrough leads to another and another, and it just keeps pushing the limits of what's possible.
And to think, it all started with that one guy back in 1911, dreaming of using electricity to explore space.
It's amazing and just incredible human ingenuity. And it makes you wonder, what other impossible dreams might become reality, in the years to come.
That's the best part, right? We're always learning, pushing further into the unknown.
It really is. And as we wrap up our deep dive here, I want to leave you, the listener, with this thought. What role do you see electric propulsion playing in our future? What gets you excited about all this? Because this isn't just about, some cool technology. It's about the dreams it inspires, It's about our hopes and ambitions for space exploration. So keep exploring, keep asking those questions, and keep looking up at the stars. Who knows what incredible adventures are waiting for us out there?